So welcome back to another Inventor tutorial. We're going to look at motion constraints in more detail using a simple CAM toy system. So let's jump on in and see where we end up. So I've jumped straight on into an assembly, and the first thing I'm going to do is I'm going to use the component place function. It may be set up with place from content center, so you just drop it down and you just want the place component function. And I'm going to select the two, do the vertical frames to start off with. So I'm going to place one, and I want to get it orientated so that they're opposite each other. So I'll place the first one in position, and then if I right click I can then rotate it through various different axes until they're the right orientation for me. And you can rotate through all three axes, so they're now opposite each other, so that's perfect for what we want. We will now place a couple more components, so we're going to do the camshaft. That's already orientated roughly in the right direction, so that's good. More components, we'll do cams. So we want 3 of these. Again, we're going to right click and we'll rotate them so that they're orientated roughly in the right plane. Then I'll just place 3 of them. 3 of them. Place more components. We're going to do the top frame. Again, we'll rotate this one so that it's the right way. There we go. Place that one over here. And we now need to do the last component, which is our pins. And we'll do the same. Well, they're orientated roughly in the right direction, so we'll just put 3 of them there. So I will ground the one of these vertical frames. So I'm just going to select it and then right click and just select the grounded function from the drop down. This will mean that it's now pinned in place and it can't move. So we now go through the process of using our joint or constraint relationships to constrain the various different objects together. So the first one, I will go with a constraint. I'll keep it as a mate at the moment, and I'm looking for the axis of the actual shaft. And I'm going to marry it with the axis of the whole of the grounded vertical frame. I'll click apply, and then you'll see that we can move it around itself and we can move it in and out of the hole. We just need to make the end of the shaft flush with the face of the vertical frame. So we'll do another constraint here, and we'll select the face of the shaft and the face of the vertical frame, and we want them to be a flush solution, which will bring them back into alignment. So we'll click apply, and then we're going to do the axis again with the axis of this hole. So we'll do constraint axis of the shaft with the axis of the hole. We'll apply that one. Now this can move in various different directions. So first of all, what we want to do is have the bases on the same plane. So we'll constrain the base of the grounded object with the base of the non-grounded vertical top frame. Again, it'll be a flush, and we'll apply that. And now it's going to be in the right same angle as the other vertical frame. We now just need to make the two faces of the shaft end and the face of the vertical frame flush constraint. So we'll just come over, select the face of the shaft and do the same with the vertical frame. Again, it's a flush constraint and we'll apply those. So fully constrainted the right hand side and grounded the left hand side, and you should find that the actual shaft now rotates, but doesn't only rotates through that axis but doesn't move in and out. So that's exactly what we're after. So the next one we're going to do is the camshafts, sorry, the cams on the camshaft. Again, we're going to work with the axis and then we're going to marry up the flat sections to each of the flats on the actual camshaft itself. So we'll do the axis first, and we'll select the axis of the camshaft. We'll apply that one, and we'll move it to one side so we can actually see the flat section, and then we will select the face of the where the shaft goes through, and then we'll select that face on the actual shaft. And we'll apply that. Now it won't it'll rotate with the shaft, but we need to get it actually in position. So we're going to marry a face up with a face, this internal face here. So we'll constrain the face of the cam to the face of the cutout, and then we'll apply that, and now that's solid on the shaft and forces the shaft to rotate as the cam rotates, or vice versa. So we're now going to do that for all the other two, so I'll just quickly do those. It's the same process again, so we're doing the axis with the axis. We will move it to one side so we can see the flat nice and easily. Do the same on the shaft, and then we'll do the face again with the face. Apply those. We'll do the axis again. Again with the flat. And again with the face. And we're just limiting the degrees of freedom to what we need and what we want. So we'll do the top frame now. So we'll constrain, again we're going to do an axis through the hole that's drilled in the top frame with the same hole in the vertical frame. And now what we've got, we now need to marry up the faces and then also stop it rotating by doing another axis on this on one of the opposite holes. So we'll do that first. And then we'll do the faces. Ooh, press cancel when I shouldn't have. So I'll just do that again. And now that's locked in place between the two vertical frames. Now for the sort of pins, I'm going to use a joint constraint, and I'm going to select the bottom of the pin, and I'll just select the bottom hole of the on the top frame. Now if you get to the point where you can't actually grab the bottom hole, if you hold down control while you find that you can then move down the three dots by holding down control, and you can select the bottom one nice and easily. Cylindrical is what we want. It's automatically done that for us, so we can apply that one, and we'll do it again, same positions for all three pins doing the control, holding down control as well, so I can select the bottom one. Okay, so we've now got these pins that will move up and down, but they also rotate, so we're going to have to just line up the face of the edge with the face of the cam. So we'll just do those now, and just using a normal constraint, a mate. We'll make sure they're flush as well, and we'll just do that for all three of them to their individual cams. Do that one again, hit cancel, should hit apply. Try that again. Flush. Okay, we can apply that. There you go, it worked that time. So now we've got the cams that will rotate round. We've got the pins that will move up and down. We just need to attach them to their faces. So we want the bottom face of the pin to follow the cam shape as it goes round. So we'll use another constraint, and this one more time we're going to use a transitional constraint. We'll select the bottom face of the pin, and then we'll select the face edge of the face of the cam itself. When we apply this now, when I rotate the cam, you can see that the pin moves up and down with the cam. So all we've got to do now is do all three of them. So exactly the same transitional constraint, and again for this one. And again, as long as we're selecting a face, it doesn't matter, it will always follow around. So this cam has got like 4 or 5 different faces on it, on that edge, but as long as we select one of them, it'll be fine. So now all we need to do is create a constraint of an angle, so that we can get so we can drive the constraint and create the motion. So for that, we're going to have to remember that each individual component has its own origin, and we can use those origins to create an angle constraint. We could also see if the origin of the actual one of the origin planes of the actual assembly drawing works, which it will. So I'll turn the visibility on, and I'll turn the visibility on of the one of the origin planes of the camshaft, which will be our XZ, and we now can create a constraint, an angle constraint, between the plane of the camshaft and the origin plane. They need to be a directed angle, and we will just leave it as that. Just click apply, and then we cancel it. Now we can turn the visibility off of those 2 planes, and if we now find the relationship in our relationship, and it'd be the obvious one because it's the one that's got angle, right click on it, click drive, we'll get this pop up here, and we'll change it to just a 3600, and then press play. And as the camshaft rotates, the cams rotate and the pins then will move up and down in sequence. So that's the end of this demonstration. Come back soon for some more Inventor tutorials.